Hi, it's Bentley's mom, Miss Bowis. Okay, we're gonna do the chapter 11, lesson 5 homework using mean, median, and mode. We're gonna do the guided 1 through 2, independent 1 through 4, and the hot problem number 5. So with the guided, it says the table shows the required temperatures for different recipes. What I'm gonna do first is I'm gonna put them in order. So we have 175, and then we have 325, 325 again, then 350, 350, 350. There's 3 of those, and then 400, and then 450. Okay, so we have a total of 1, 2, 3, 4, 5, 6, 7, 8 numbers. 1, 2, 3, 4, 5, 6, 7, 8. Okay, just making sure. Okay, so A, it says, what is the outlier? Okay, the outlier, it says identify the outlier. Okay, so if we look here, again, we're looking for a number that's way extreme value, either really small or really large, once your data is in order. So here, between 450 and the next number, do you see how there's only 50 between those? So that's not that far. Then between 400 and 350, there's only 50. But if you look over here, between 175 and 325, that's 150. That's pretty far. So my outlier here is the really small number, which is going to be 175. Okay, then B, how does this outlier affect the mean, median, and mode? So the first thing is let's find the mean with the outlier. Okay, so if I include the outlier, 175, I'm going to add all of these up, okay? And when I do that, I get 2,725, and I'm going to divide it by how many numbers there are, which is 8. And I get 340.625, or approximately, I'm going to use my squiggly equals, 341. This is the mean. Okay? And then the median, the middle number, we'll find the median and the mode. The middle numbers, you go 1, 2, 3, 4, 1, 2, 3, 4. It's a tie between those two. And if they're the same number, then you just use that number, 350. If not, like you would add them up and divide by 2. In this case, you'd get 700 divided by 2, which is 350. Now the mode's the one that occurs the most. So Bentley, which one occurs the most often?
350.
This one occurs twice, but 350 occurs 3 times. Yep, so it's going to be 350. Okay? So you notice here the median and mode are both 350, and our mean is 341. And, okay, let's see. Then, without the outlier, okay, so we're going to do the exact same data set, but we're not going to include the 175, okay? So we're going to do it now, the mean without the outlier. Okay, so we're going to do the 325 plus 325 plus 350. That's times 3 plus the 400 plus the 450. Okay, put that in your calculator first, and then hit enter. If you're using a graphing calculator like a TI-84, the calculator will do GEMDAS or PEMDAS. You must put parentheses before it, which are above the 8 and the 9 keys, and then you can hit divided by how many there are in this case, which is, now there's only 7 numbers because we're not using the 175. And so you get approximately 365. Okay, so now if you look at this, let's do the median and the mode. Okay, now this data set, okay, when you still find the median without the 175, you still get 350, and the mode, that also doesn't change. Okay, so using the outlier, it's asking us, how does the outlier affect the data? Well, in this case, it did not affect the median or the mode, but it did affect the mean quite a bit. The mean here is 341, and the mean here is 365. So the median and mode did not change, but the mean was actually 24 less with the outlier. So with the outlier, because that was a small number, it shifted the mean, 24 places, which is quite a bit. So that's what was greatly affected, was the mean. Okay, now let's do, it says C, tell which measure of center best describes the data with and without the outlier. In this case, because the median and mode are the same, without the outlier, I'd say either one of those is fine. With the outlier, same thing. You don't really, when there's a big outlier, you don't want to use the mean because it can change it. So in this case, the median or the mode, because they're both the same, would work. I would probably, actually either one's fine as long as you explained it. If you said, the mode's right in the middle and there were 3 of them, therefore I thought the mode was a good measure, that would work. If you said, the median, because there was an outlier and the median was right in the center, I used the median. That would also work. Both of those are great measurements for this. Okay, now we're going to go to the guided, that was a guided practice, sorry. We're going to do the independent. So turn the page or go to the next one. We'll do independent 1 through 4. Okay, so independent. All right, so it says the number of minutes spent, so we're doing independent now. The number of minutes spent studying, they give you a list of numbers. I'm going to put that in order from least to greatest. So we have 35, 45, 45, 60, 60, 70, and 80. Okay, so it's asking, find the measure of center that best represents this data and then justify your answer. So if you look at this, if I look from 35 to 45's, 10, from 70 to 80's 10, there's not an outlier here. So because there's no outlier, I'm going to choose to use the mean. Okay, so you can say I'm using the mean. Basically, you can write because there's no extreme values. That's a good reason, or because there's no outliers, something like that. And then what we're going to do is add all these up. Okay, and when we add those up, we get 395. Okay, and remember in your calculator, if you have a graphing calculator, you can put parentheses around this and do it all in one step. Otherwise, you need to put this addition problem in and hit enter first. You get 395 and then divide it by 7 and you get 56.4 or about 56. Okay, so again, I would use the mean because, you can write because there are no extreme values. Or you could also say outliers, okay? So that's number 1. Okay, number 2 of the independent practice says, let's see, it says the table shows monthly rainfall in inches for 5 months. Identify the outlier in the data set and then determine how the outlier affects the mean and median and mode of the data. So the first thing I'm going to do is write this in order from least to greatest. We have 2.43, that was in November, 6.14, 6.47, 7.19, 8.38, and 8.63. Okay, so hopefully by now, let's look and see if there's an outlier. So Bentley, if you're looking at this data, does it look like there's an outlier?
Yes.
What?
2.43.
So, yep, 2.43, a really small one. Now remember, your outlier can also be over here. Like if I had a number like 16 or something way out there, that would be an outlier on the other side. But between this it says 8.63 and 8.38, that's less than 1. And then there's 6.146. So yeah, the 2 is way, way small. So that's going to be our outlier. When there's an outlier, it's going to affect the mean the most. So we're not going to use the mean. Okay, so we're going to eliminate mean. And we're either going to use the mode or the median. So, is there a mode, Bentley? Is there a number that occurs more than once?
No.
No. There is no mode. So when there's no mode, you obviously can't use the mode. So we're going to use the median. And the reason why we're using the median is because there is an outlier, okay? And nothing repeats. So that's why we're going to use the median. So we're going to go like this, 1, 2, 3, 1, 2, 3. These guys tie. So we have to find the average of those. So we're going to do 6.47 plus 7.19, and we're going to divide that by 2, because I can't really look and see quickly like the number in between those. So it's 13.66 divided by 2, and we get 6.83. And this is our median. Okay? And so when it says to justify yourself, you can say, because there was an outlier and no numbers repeated. Okay, and that's why I chose to use the median. Okay? And this doesn't have to be exact, your reasoning, but just write a sentence justifying why you chose to use the median instead of the mode or the mean. Okay, that was, let's see, number 2. Okay, now we're going to do number 3 on the independent. Okay, Bentley, will you check and make sure that that I'm not writing too small? Okay, the table shows an average depth of several lakes. So the first thing I'm going to do is I'd write your data in order. Let's look at the chart. Let's read the question, see what it's asking. It says identify the outlier in the data set. Okay, so the first thing, I could just look at the chart really quickly. If we write it in order, it's 10, and then 14, and then 24, and then 43, 62, and then 1,148.
Oh boy.
Okay, so Bentley, where's your outlier here?
1,448.
Yeah, so the outlier is 1,148. That is a very, hopefully, obvious outlier. It's way big, okay, compared to these. So because of that, I'm automatically not going to use the mean, okay? Because it asks in B, how does this affect the mean? So for B, for the mean, I'll say it affects the mean greatly, and we'll make it bigger because this number is so huge. The mean, when you do this, is going to move it way over towards that 1,148. So it's going to greatly affect the mean. Now for the median, does this outlier affect the median that much? No, it might affect it slightly. 1, 2, 3, 1, 2, 3. So we're looking for the number between those two. But if that wasn't there, we'd get to 24. So it's going to slightly move the median, but it's just going to slightly affect it. So I'll just say it's going to slightly affect the median. Okay, because so the median, it's going to push it over, towards the bigger number. And then the mode, is it going to affect the mode at all?
Nope.
It's going to be no effect on the mode because there's nothing that repeats twice. And the reason why, when there's an outlier, if there was a 5 outlier, like 5 1,148s, then it wouldn't be an outlier. So that's why it's not going to affect that. Okay, so you can write that in your words of your own. Basically, identify the outlier would be this, which is the Crater Lake, and then just how it would affect it. And then it says, tell which measure of center best describes the data without the outlier. Or it says with and without the outlier. Okay, so for C, okay.
I have a question.
Yeah.
So what happens if you get just say 5 of them on the chart are 5,000 and 5 of them on the chart are 100? What does that mean?
Okay, so that's the mode. So if there's a whole bunch of 100s, then that's going to be the mode. And so if there's a whole bunch of 100s, then the mode would be.
There's 5 100s and then there's 5 5,000s. Are they? Would they be considered outliers, or does that?
No. So it depends on how.
Explain to me
there
what
can be
that
more
means.
than one outlier. Okay, but right now, with what you guys are doing, because this is a low level of statistics, you guys are, this is 6th grade math. I think you're 5th graders, but you're 1, 2, 3, 4, 5. You have 6 pieces of data. If you're looking at where there's 1,000 pieces of data, and there might be 4 or 5 outliers, there could still be that many outliers. But when you only have a low number of data, you're usually only going to have one outlier. Now, if there's only like 6 numbers and 3 of them are 1,148, then that's not an outlier anymore if half of the data is really big or really small. So you can still have data that's really like 3 that are really small and 3 that are really big. And then you just have to look at it and go, okay, what's the best measurement for that data? So you have to look at each data set individually and decide, what's the best way to describe this, the mean, median, or mode? And that can change. So that's a good question. Now on here, I feel like the best way to describe this would be the median. So I'm going to do 24 plus 43, and I'm going to divide that by 2. And I get 67 divided by 2, which is 33.5. And that's the median. So I feel like that's the best way. And the reason why is because there's no mode, nothing repeats, and there's an outlier, which would eliminate using the mean. Therefore, I would use the median. Now, without the outlier, so this is with the outlier. So this is with. Now, without the outlier, I'm still going to find the median. So my data is just going to be 10, 14, 24, 43, and 62. I'm leaving out my outlier. So in this case, it's going to be 24. So without, the median is 24.
16 and a half minutes.
Okay. All right. So let's hurry. Let's go to the next one. Okay. Number 4 on the independent is basically this chart. And it says mean, median, and mode. Okay. And it's asking, how can the outlier affect it? So Bentley, what do you think? The mean, how does the outlier affect it?
Well, I mean, the mean is
this will affect the mean the most. It greatly affects it.
Like if you have 10,000 and you have 10 20s.
Okay.
10 20s are 200 and 1,000 is, well, it's 10,000, 10,000. So in between 10,000 and 20, you're going to get something like, I don't know, a lot bigger than 20.
So outlier can greatly affect the mean. So if it's really big, it's going to make the mean bigger than the center of the data. And if it's really small, it's going to make it smaller than the center of the data. Okay, the median, it's probably going to slightly affect it because it'll only, when you go to the middle like this, so if you take out an outlier, it can shift it, or the outlier can just kind of make it go, to the next number, left or right, but it's not going to greatly affect. It's just going to move it over 1 or 2. There is a chance that the median cannot be affected if you have a really big, because there can be more than one outlier. If there's a really big outlier and a really small outlier, and those both get eliminated, the median, if there's one here and if there's an equal number on each end, the median would still stay the same. So it'll slightly affect it, or maybe not at all, depending on how many outliers there are. The mode, though, an outlier shouldn't affect the mode.
Affected at all.
I'll just say won't affect mode. And the reason why is because an outlier should be a number kind of all by itself that's nowhere near the rest of the data. So if there's 5 of those, then it's not going to be considered an outlier. Even though it's far away, if there's a whole bunch of them, it's not an outlier.
It changes the number occurred, and
that won't happen.
Which
Okay.
makes it
So next, let's go to 5 of the hot problems. Okay, we have find the error. Pilar is, so this is the hot. It says Pilar is determining which measure of center best describes the data. So I'm going to put these in order. So we have 12, 15, 15, 16, 18, and 44. Okay, find her mistake and correct it. Okay, it looks like what she did, it looks like a problem where she added all these up and divided by how many there were. But she did not include this outlier, the 44. So if I add these up, okay, and divide by 1, 2, 3, 4, 5, 6, divide by 6, I'm going to get 120 divided by 6, and I get 20, and this is the mean. Okay, so we're trying to find her mistake. So her mistake was she didn't even have this. She just excluded it completely. When you're finding the mean, you're not allowed to just exclude a piece of the data set. Okay, so basically I would say something like, Pilar did not include 44 in finding the mean. Okay, I also would probably say that this looks like an outlier to me. See how big 44 is from the rest of the data? Everything's between 10 and 20, and then you have 44. So because of this, I would not use the mean for this data set. So you could also say something like, when she found the mean, she didn't include 44. Also, because 44, I would say also 44 is an outlier. Therefore, the mean is not the best measure. Okay, so in this case, and then it asks you, what would you use? So looking at this data, 1, 2, 3, 1, 2, 3, the median is good. The median is between 15 and 16. So the median would actually be 15.5. And the mode, can you see the mode down here, Bentley, or is it too low?
That's basically the lowest.
Okay, it's 15. So either one of those is fine. You could say the mode because the mode is in the middle and 15 occurs twice, or the median, which gives you 15.5. Either one of those is better. But I would not use the mean because there's an outlier here. Okay, so when there's an extreme outlier and an extreme number either direction, the mean will be changed quite a bit. Okay, and that's it. Have a great day. Bye.